what happens to the prime factorization of a number when you triple it? Well, let's look at 20. 20's prime factorization is 2 times 2 times 5. If you triple it or multiply it by 3, the prime factorization becomes 2 times 2 times 5 times 3. So when you triple a number, it just adds a times 3 onto the prime factorization. It says, part B says, can a perfect square be 3 times as large as another perfect square? The answer is no, and here's why. Remember, when you find the prime factorization of a perfect square, there's perfect symmetry to it. Every number on the left has a match on the right. So like 100, for instance, 10 times 10, and then that's 2 times 5, and then 2 times 5. Again, the 2 has a match over here, and the 5 has a match over here, right? If you triple it, that symmetry is still going to be there. It's still going to be 2 times 5 and 2 times 5, so you're going to get the matches, right? But then there's just going to be one additional 3, which can't be a perfect square, because if it was a perfect square, there would be a times 3 over here as well, but there's not. So you can't have a perfect square that's 3 times as large as another one because of that reason. So part C says, can you find a fraction of integers that makes this equation true? The answer is, again, no, and here's why. If you try to put a fraction in here, like 9/5, and you square it, you're going to get 81 over 25. But no matter what fraction you put in here, when you square it, you're going to get a perfect square over another perfect square. And we want that to equal 3. Well, we just figured out that you can't have a perfect square that's 3 times as big as another one. So you're never going to get a perfect square over a perfect square to equal 3. And any fraction you put in here and square it, you're going to get a perfect square over a perfect square. So you can't find a fraction that you put in here to get the perfect square over the perfect square to equal 3. So you can't find a fraction in here that solves the equation. So it says, explain why the square root of 3 is irrational. Well, we know that the correct, accurate solution to this is the square root of 3. That's the answer to this. You put in square root of 3, it solves it. Okay, so the solution to this equation is the square root of 3, but we also just proved that you can't find a fraction solution to the equation. So if the solution to the equation is square root of 3, and we also showed that you can't find a fraction that solves it, well then the square root of 3 apparently can't be written as a fraction of integers. So there's your proof. Square root of 3 cannot be written as a fraction of integers.